So yes, my name is Daniel. I'm coming from Germany. I'm originally from Romania, and practically I'm speaking mainly SIP from 2002. The history, and I was introduced with a couple of projects. It happens that, you know, in open source you can get an evolution that sometimes you cannot control. So the initial project was a SIP Express router, and it was open sourced by a research institute in Germany. It got quite popular. It was a special design. It was more or less at the time when Asterisk also starting looking at SIP. So it was the early years of SIP as a protocol for voice over IP. As it happens also in business, at some point in time the project was going more into the business than into the research, and the institute sold IPR to a US company, and not being clear what's going to happen with the public project, we created a fork of it. At that time we named it OpenACR for obvious reasons. You can see how we wrote it with uppercase ACR, so we can refer still to the old origin of SIP Express router. Unfortunately, 3 years later, like 2008, we got in another issue with the name. Some US company that it owned ACR.com at that time claimed that we suggest its open source version of their product, and they had a trademark on ACR as a word. And as we are mainly based in Europe as developers core team, we decided not to go in court in US to challenge that. And you know, even being here could be something difficult. You need resources, money, humans, and so on. So we decided to rename it, and we got into Kamailio. And everyone is asking what's Kamailio meaning. It's actually related to US. It's a Hawaiian word, and it's the verb for conversation, to talk. So if you translate from English to Hawaiian, let's speak SIP, it's like I Kamailio SIP. Or I don't know how they exactly pronounce it, but it's how they write it there. You know, we got all we needed for a name, free.com and .org, no trademark on it, and nobody actually using it. It was like searching with Google, around 10 results, because street in Honolulu has the name Kamailio. So we have a name before we actually started. And here we are. After many years, it's practically the same code base as we started, the same architecture, the same target market. The difference is in the name, of course. There are other forks at some point. We got good recognition out there with a couple of awards. For a point of time, we even merged back with the SIP Express router and had like dual distribution, Kamailio and SER. Later, we decided to merge them complete back, and as Kamailio is something that we control as a trademark now, we decided to use it further. So this is the history. I know that there are sometimes issues with people pronouncing it, and I think we got the best moderator here in the room, and I want to thank by showing how to. So we have a jingle, we have a voice with Alison in the back. Thanks for recording that back in 2008, I think, with Ole Johansson's support. So now going actually to the technical side and understanding what's a SIP signaling server. So actually it's going to be the only voice processing we do. It's playing this jingle at via web or conference. Otherwise, Kamailio itself is handling only signaling packets, and that would be SIP requests and responses. Because of that, we have a lot of flexibility. We get access to like raw traffic on the network. We can decide what to do with it. So have in mind that SIP doesn't mean telephony. SIP is more than telephony. And when it comes to telephony, we don't really have the concept of the call. You have to manage everything that belongs to a call, and you decide what to do with it. And that gives you a lot of benefits in terms of scalability, also reliability, as well as flexibility, because accessing raw packets, you can extend it very easily. So don't look at Kamailio for like initiating calls, answering calls, or audio video processing. No IVR, no nothing. You know that in IP and voice over IP, there are practically 2 channels. Could be SIP as a signaling, but could be H323 and other YACs, for example, other signaling protocols. We are just taking care of signaling. Content is not our business. So you may think that, well, yeah, for telephony, as here the subject, it's telephony as a main topic, what I should do with a signaling server, a SIP signaling server. So if you look at real-time communication where voice over IP is part of it, we'll have this multimedia type of communication where it's telephony, voice, file transfer, so anything which is a media, including gaming. If you were before at Peter's talk, you could see that you could do video as well as playing tic-tac-toe in the same session. But it's a lot behind, like, you know, instant messaging, presence, a lot of alerts, monitoring, and even mobility. It's done via signaling. So I try to categorize it from other point of view, like human interaction and maybe non-human, like every other thing. So telephony, video, file transfer, this will be more at the action of a user, a human, and the rest could be from every other thing, including humans. So you can be sending messaging, but doesn't mean that someone has to be there to answer and have a session. Could be stored, could be routed as you need. So now let's look at what I call it as invisible signaling, because you as a human, you look at your phone and you know that you are doing some action from time to time, but actually behind that, it's a lot of signaling. So if you do telephony, it's not just initiating a call, you have to do registration. The server has to authenticate you, so you don't pretend to be someone that you are not. Then we know that we live still in an IPv4 world, which is dominated now by a large proportion of NAT home users. So then you'll have to send keep alives to keep the NAT pinholes open. Then if you go for like a large platform, you need to monitor between the servers and eventually transfer states. From telephony point of view, during a call, you don't actually see that the server is trying at the best to choose the route, like sending to a gateway is not available for whatsoever reason, like it's full, the channels, no more channels. The server will try another option without you doing anything like redial. You don't need to do that. This is from user perspective, but also from business perspective, could be like list cost routing, choosing the best route, and then if it's not available, choosing the next one. And as we know, you can do session updates. You are on a call, postman is ringing, you say, wait a bit, you put it on hold, come back in a minute. That's actually signaling that happens behind the scenes. So I'll try to get it to some numbers as I adapted talking with the people in the first day, and some of them being just telephony engineers who are not really getting where will be a role of the signaling. So I try to show you the quantity of the signaling that it's happening behind you or behind a SIP device or a telephony device. So I really took the basic like profile, you know, a guy that is not really into, or a person that is not really in a lot of communication, to see that actually behind it's a lot more. So the typical day of a person at home in the morning, then working, then back at the home, and okay, going out with friends, it's not really that much changing the profile. And then, what would be the activity from, you know, a telephony point of view? Let's say in the morning, 3 to 5. At work, I put 0 to 2, just in average, maybe, you know, your kids at home or you have a day off. And in the evening, more or less as in the morning. Of course, no big events happened in that day. That keeps you talking and calling your friends and so on. So again, I was trying to put the lower profile of activity. So let's look at the signaling, what happens for each of these activities. So this would be a call from point of signaling. You'll have an invite. The server will have to authenticate that it's the one that pretends to be the caller ID. So we'll have to apply the right profile, prepaid, postpaid, and so on. So that will be all challenging. Then we'll have to be another invite. Of course, you don't have to introduce your password each time. You configure your phone, and this is done behind, but it's done always. It's not done only when you add the password. After an invite, you have a set of what they are called provisional replies, 100, which is trying, saying, okay, I got it, I see what I'm doing with it. Then when the phone is ringing, 180, 183 if you send some early media. And eventually, at some point, someone will answer the 200 OK. Then we'll have an ACK for confirmation. And I put here just like a reinvite plus the end of the call, which is a bye, plus the response of that request. So this happens all the time when you do a call in, again, taking it as an average, because could be a lot of like session updates in a call, not only reinvites, but also updates or options or info requests. That would be something more complex that I didn't want actually to put, to have a view from lower end point. So that was the call, but then we will have registration. And registration is the process where you say, or the phone is advertising the local IP address to the server. So when someone is calling you, the server knows where to send the traffic. And again, we'll have authentication for each register. This is a periodical operation. So the phone will have to do it every, I don't know, 1 hour, half an hour. It's up to you to choose this one. By default, or not really by default, but got common there that most of the phones are predefining 1 hour of registration interval, which many find it now too large. So they kind of lowering it. But again, I'm trying to take the example which has the lowest impact in signaling. So I have the register authentication with 401 challenge, then register with the proper credentials. And for 1 hour, practically nothing happens from the point of view of registration. But now, being at home behind the net, if there is no traffic during that hour, the net will block the traffic coming from outside. So you need to keep sending some packets, and it has to be something like 20 seconds or, I don't know, even lower sometimes, or 30 seconds, you will have to discover it. So I tried also to get the average of what I'm using for the 20 seconds. These keep alive are typically options. Some phones are doing notify. For Kamailio, it's configurable because it can be done by the server, or if you know your client, you can say the client will do it, the server doesn't have to do it. It doesn't matter, at the end of the day, it will be the same load of signaling. So we'll have like 3 options with the reply, just to keep per minute, to keep communication open, and eventually someone is calling. So I try to do the math just to get it to a better visual situation. So for a call, like in average 10 calls per day, you'll get 120 packets. And for devices just sitting there, not doing anything, but being available if someone is calling you, it's a lot more, so it's getting close to 9,000. So this would be one phone, but we are more in the core network or in the infrastructure, and we don't deal with one user. So practically, you can have loads of users, no matter you use Kamailio or it's just Asterisk, you can put many of them. So if you just multiply with 1,000, you get to like 9 million requests that, or messages that you have to process. And if you go to 1 million users, could be not only personal users, could be, again, some gateways, could be some other type of devices. Sometimes just having these numbers, it's not relevant. And we do have deployments with more than 1 million. One of our main contributors is the Second Telecom in Germany. So they have a couple of millions of subscribers. So I tried to translate it into bandwidth. And I'm not considering the WebRTC, where what we knew as being the average SIP size message, it's completely different because we have a huge SDP. I try to put it like 1 kilobyte in average, which makes the computation easier. But practically for 1,000 phones, you'll have like 9 gigabytes of traffic that you'll have to handle on server for 1,000 subscribers. If you go more, you know, trying to overtake Skype or Facebook, so thinking of millions of phones, you can get into the terabyte of processing of signaling. So you don't really see it, but it happens. And I'm not talking here about situation like you do retransmission because of some network problems or your clients are on mobile, which are slower. That will increase your traffic a lot more without you seeing it as a user. And of course, did I forget anyone in my numbers? Yes, your friendly scanners. So that was like a legit traffic, but now I think it's taking less than half an hour from the moment you fire up like an Asterisk on a public IP till you get someone scanning you. And from that moment, they'll do dictionary attacks, trying to discover your passwords and then trying to do some fraud, you know, calling expenses, destination, and so on. And this I just put it like 100 requests per second scanning, so it will be also some reply following it, will be like 200 messages per second. And as you can see, could be a lot of traffic if you don't put some other protection in front of your telephony. So trying to summarize a bit what I wanted to give as an introduction and trying to spot the role of a signaling server. So can be a significant source of processing, even if you like it or not. Even if you have 100 phones, you can get 2 of these guys flooding you like vicious or friendly scanner, sending you a lot of packets, and that can crash your infrastructure from different point of view. And again, those numbers are actually estimated for a very basic usage model. Typically, you can have a lot more just on the signaling. Now, on the subject of the presentation, I'm trying to give you an idea where Kamailio can replace it either alone or together with Asterisk or another SIP device like a gateway to make your life maybe easier, but also from the point of view of scalability and extensibility. So you can run it as a main signaling server. You don't really need a back-to-back user agent. You don't really need a media server. If you don't have like an IVR menu, you don't want to have voicemail or audio conferencing, you can just deploy a SIP server, configure the phones to register to it, and you can call between them without any other application. Then you can have it as an edge proxy or an edge signaling server. So you put it in the front of various other, let's say, SIP application servers. Could be actually a Kamailio there, could be an Asterisk, could be, I don't know, a gateway to Twitter for instant messaging and so on. It's up to you or your requirements. Peter had it in his talk with facing WebRTC traffic with Kamailio in front of Asterisk, as it was mentioning dispatcher. So this is for load balancer. There are a couple of alternatives. I tried just to give an indication of what you can use. I'm not really going to focus on the technical part. I put it there so you can understand it's not that complex. I should make a remark that might look a bit complex for you. Our configuration file language, which is kind of scripting language, which is not really dial plan. Again, SIP is not about telephony. So this is more like a logical language, and you have to process every request you received. And we don't do anything implicitly. It's you that decides what to do with a request. If you send it to a wrong point, it's not our fault, it's your fault because you didn't put it right in the config file. So dispatcher module, it's one that you can use it for load balancing, and you have lots of options like doing call-out distribution, round robin, hashing algorithms, weight distribution, and so on and so forth. In the config file, after you authenticate and do the basic checking, you just call this route dispatch, and it includes also rerouting. So if the first selected asterisk is not responding or it's busy, then with this config, you reroute to the next one. Another typical use for a proxy together with Asterisk or SIP application servers, it's interconnecting your infrastructure with others. And the example here would be with some PSTN providers. Typically, when you get the traffic from the PSTN, it would be like DID mapping, which Asterisk is serving this, which tenant, and so on and so forth. You can collect all the traffic in a single Kamailio. You don't need to give to the provider 100 IP addresses. You can even actually run everything else apart of Kamailio on a private network. You don't need public IP addresses. We have helper application that we could relay also RTP, we just don't process it. The other way around, from you as a business, it's important to have the least cost when sending out to a provider. So again, you have two directions here. Depending on the direction, you do least cost routing or you do DID routing. The example here is with least cost routing. We have the LCR module. You can choose another module. The example is it's with LCR, also with the rerouting option. As I already mentioned, the friends we have out there without actually meeting them, unless actually they will meet our account in the bank if they succeed to go through our telephony platform. So you can use a SIP signaling server, and Kamailio has plenty of options as a SIP firewall, so you can protect against malicious traffic. Here, it's up to you how to decide it. Typically, you have to trust some points, like a PSTN gateway. You don't really start profiling it. But otherwise, if it's like residential, you expect to be no more than, I don't know, 5 to 10 requests per second. If someone is sending more than that, it's something wrong. It's trying to scan you. And then you can also count failed authentication in a row. So if it's failing 3 times in a row, you can disable that account, or you can send an alert to your operation that they will watch it. So this is also part of the configuration that you decide. We don't really have implicit rules. We give you the tools. You decide how much you, or for how long you block an IP address, or for how long you suspend the user so you cannot really authenticate, and you can automatically enable it. Like, don't authenticate for 15 minutes. After 15 minutes, you can give it another chance for 3 attempts to provide the right password. Maybe you're mistyping, you are in Vegas after the party this evening. I'm sure if someone is requiring you a password, you can do some typos there. We can do transport layer gatewaying. Like you saw with WebSockets, we can receive traffic on WebRTC, WebSocket layer, or we can receive UDP, TCP, HTTP as well, which is rather new protocol. We do also IPv4, IPv6. So it's combination between these, and as well as bridging between public networks and private networks. So you can do all these combinations. It's quite transparent if you don't really need to force something. But I give here the example, like I receive over whatsoever and I want to send out via UDP, you just force destination URI to use transport UDP. If you want to force a specific interface, like public interface or private interface, you can force the send socket, and then you just relay and you're ready to go. As an edge proxy, you can do a lot of offloading of signaling processing to your SIP application servers. So you can take on you user authentication, all this, computing and challenging and stuff like that. You can absorb, like keep alive send from the server for NAT traversal. You can fix the signaling for the phones behind the net. You can do a lot of routing options like parallel forking. You want to spread and have a call ringing in many devices at the same time. You can do serial forking. We can do a lot of telephony features because a lot happens when the call is initiated. Once it's done, you have caller and callee and they just need to talk, and then practically you forward RTP packets. But before the user is not available on the office phone, send it to the mobile. You can have the rules of not accepting calls from someone because it's, flooding you or it's not a friend anymore. You can block it from the point of view of caller or from the point of view of callee. That will protect if someone is breaking in your system, somehow discovers a password, you don't allow calls to Nigeria at any time. So you can have it in that way. Also, like DNS handling, which could be heavy at some point, you can delegate it in edge proxy. Also, by the design and what we are doing, we have a lot of options for scalability, combining replication and forking to have to be capable of handling a lot of traffic. Could be sometimes not really from server availability, but could be from geographic availability of your platform. And being at signaling layer and actually dealing with the raw packets we receive at the SIP, you have a lot of flexibility in, adding extra services like instant messaging, presence, gaming. You had a demo before, although once the game was established, they were using something else, but getting into that notification. We do more than C because we are required by specs like XCAP server would be for management of your buddy list, MSRP for chat-like instant messaging, so session-based. We do have a lot of IMS extension for those that are familiar with telecom environment and mobile operators. But then we don't really care about what you are sending to us. You just need to follow the SIP format, request format, like request type, address where you want to send it, and the headers. You can use your own methods just to extend and have new features. So as I said, this would be like standard here, message, notify, invite, publish. But you can use turn right to discuss, like instead of invite, you can send that request to a card or to a browser, could be like tic-tac-toe. You send it to the Kamailio with that method and we don't complain because it's not our job to understand it. My job as a proxy is to know where to send it out. So extensibility, it's really a key point, and I would like to see more into the SIP space. So not really trying to play with what the guys at ITF have defined it. Have an idea, define you can do it via method or you can do it via custom header or via custom body, we don't really care. You just need to keep the format with the request URI, some headers, route headers, and so on. So coming slowly to the end, to conclude, what would be a SIP signaling server suitable for? You have a lot of subscribers, you have a lot of traffic, good or bad. You need to do some innovation. You have access at the low level of signaling. And at least myself, I do it for personal usage as well. A lot of testing, part of that. I'm not really going, I just put it, I'll have the presentation online, but also because we'll record this and will be on video. We do have a lot of features. It's up to you to use like a MySQL or SQL backend or no SQL backend. I'm not listing, or you can do, instead of configuration file, use embedded interpreters, Lua, Perl, Python, even Java, even some C# if you like that. We have everything there. Some highlights from the last years, what we've been working on it. JSON, RPC, MongoDB support, and dynamic branching of the transactions. That's a bit more, let's say, technical, but could be very useful in mobile networks, especially with smartphones. We do have also, being like a daemon, we'll have a side projects, which is called SIREMIS, that will be like a web management interface. It's more into the framework, so practically you will have to disable a lot of these options because you will never use all of them together. If you use LCR module, it's very unlikely you'll use carrier route, so you'll have to disable it. It has also options for monitoring, so displaying the activity of the server. You can see it as, you know, a front end to the data model of Kamailio plus some monitoring tool to work with Kamailio. So we are more like a framework, and if you like to give a try, you can, and you don't really like to mess with the low layer config file, there are plenty of open source projects that gives you out of the box, so you can get like an image, or you can get packages with web interface, including like accounting, billing, user interface, admin interface. That would be like C providers. Elastic 3.0 just announced it, and they are using Kamailio as a proxy in front. Kazoo Plea was also mentioned in the keynote in the morning. So these are something that are out of the box. You have a user interface. You look at the feature they wanted to implement there, and if it suits your needs, it's the way to go. If you are going more into innovation and you have something new, then you'll have to go lower layer and play with the config by yourself. So this is pretty much, we have also our own event. Next will be in May in Berlin. We're happy that we had Matt and David also this year. So again, it's kind of combination to get the best of the two projects when you put them together. So we really work closely to make the life easier for everyone. I've been also part of the AstriDevCon to make that moving forward faster. So if you want to see a bit more from the perspective of the proxy together with Asterisk, as I said, feel free to join us. And this is, hopefully now it's a bit more clear for those that have some doubts or they didn't really understand the purpose of SIP signaling server. I'm here for a couple of questions, I guess. Actually, I can have questions up to tomorrow's keynote.
I think
I'm the last speaker. Yep.
So, you said several times. You made a distinction several times about not handling media. Do you have any suggestions when you really do need for a solution to have an SBC-like feature? Peter mentioned the same thing. Like an earlier speaker said, you don't want to buy an Acme packet; it's $250,000. So
Yeah.
what do you want to buy?
Now it's a matter how you define the SBC. SBC is a commercial term. It's not really like a set of features. Like we are a SIP server, we need to follow what an invite has to be done with, and so on and so forth. Most of the people refer as SBC to an edge proxy. So we can do all this filtering the bad traffic or forwarding registration and what the SBC does. We don't do transcoding. If you look at an SBC that could do transcoding, we do kind of topology hiding, but we are not a back-to-back user agent. We can hide headers by kind of encryption, but for the purpose of scalability, we keep it so another Kamailio server can route very easily what another server was handling before. So yeah, if you, like a couple of projects use like Kamailio SBC. It's not an SBC as an Acme, but you can see it as, edge proxy protecting your network. You put it at the border of your network, and that's an SBC. As for relaying, in case the phones are behind the net, we have RTP proxy and now RTP engine that is like UDP forwarder. Of course, communicating with Kamailio for some control interface, allocating ports, deallocating ports, and things like that, but not IVR, not video or audio mixing and so on.
Any other questions?
Just a question. If you had multi-sites, you had multiple SBCs, you're using Kamailio as a load balancer, and you're directing traffic. Maybe you're directing some traffic off headers to some, and you're directing others. And then let's say you get a failure at that site. You can have two Kamailios between two different sites handling multiple SBCs that'll fail over?
Yeah. You can do rerouting to anything that speaks SIP. On the other hand, because that's a common question, we are asked about performances, and the typical question is how many active calls you can handle. That's infinite. We don't care about active calls. For us, it's a matter of how many call setups per second have. So we can handle like thousands of call setups per second. Once the call is established, we don't care what happens because the RTP typically is end-to-end or via an RTP relay. If you have a re-invite, we route it, and that's very fast. You have route headers, you have contact headers. So it's about call setups per second, not active calls. And as you switch over, if the invite was routed by this Kamailio and goes down, you have shared IP, this can route the by. The user will never notice that actually you had a switchover of high availability system.
Any other questions?
Here, Alistair.
Oh, right over here. Oh, sorry.
Or internet facing with a public IP.
Okay, so the question is how you would run Kamailio either in a private IP with some firewall forwarding on port. We can easily handle that as Amazon WHOIS got more popular, and this is a typical scenario for like scalability with virtualization. You just have to tell to Kamailio where to listen on for traffic, so that will be like private IP address and the port and the protocol, and as an extra option will be what to advertise. And then practically that's all you need to do in the config file. Now if you have like bridge in between networks, so you have to send via a private network to another box inside your local network, then you can get a bit more. But just running Kamailio behind a firewall, it's a matter of adding 3 tokens in the config file, and you don't change anything else. So it's for me, the preference is the customer preference. We are in customized solution as business side from my point of view. The other guys are doing products or out-of-the-box solution. For me, it's customer comes, says, I want to do this, and I'm doing that. I don't care. For me, I don't charge more or less for that one. It's the same. Okay?
Great. Any other questions? No?
Okay.
Well, thank you so much, Daniel. Let's
Thank
have
you,
it for
Alison.
Daniel. Thank you.